Hi everybody, Mr. Garrett here, and today we're going to talk about log properties and how to expand and condense logarithmic expressions, and also how to use the change of base rule. So let's begin. The first thing we're going to do is we're going to talk about our log properties, and our log properties are right here, and I wrote them out the way they are in the book. Log base b of m times n equals log base b of m plus log base b of n. So when we have multiplication, we add. Here is log base b of m over n equals log base b of m minus log of b, log base b of n. So division means subtraction, kind of like our exponent properties. If you remember, when we have multiplication, we add the exponents, and when we have division, we subtract the exponents. Same thing here. The other big thing to realize is that we have two logarithms here on the right side, and we only have one logarithm on the left. Over here, same thing. Two logarithms on the right, one logarithm on the left. What some people tend to do is they see this subtraction and they'll write it as log of m over log of n, and that's wrong. We don't want to do that, so we'll erase that and pretend like that never happened, but we want to make sure that that's not what we're doing. See how there's two logs on the right, and that means there's going to be one log on the left. And then the final one is log base b of m to the p equals p times log base b of m. Anytime we have an exponent, we just pull it right out in front and then multiply by the log. Now, you can see up here too, I have expand, go left to right, condense, go right to left. And you can also see these numbers. That's kind of the order that I look at. And this is just in general terms. So the first thing I look for when we're expanding is there division? If so, write it as subtraction. Then the second thing is multiplication. If there's multiplication, we write it as addition. And the third thing is I look for exponents, and if there's exponents, then I bring them out in front. When we're condensing, we kind of go in the opposite direction. We look, are there numbers out in front? If so, make them exponents. So we're going to take this and put it back up here as the exponent. Second thing, if there's addition, then we go ahead and multiply. And if there's subtraction, then we divide. And the other thing that we can do is kind of go and work left to right when we're condensing things. So let's get right into it. Let's see what happens here. The first thing we have is log base 3 of 4 times x. Now, even though it's 4x, remember it's 4 times x. And so since it's times, or multiplication, we're going to write it as log base 3 of 4 plus log base 3 of x. Multiplication means we add. If we can simplify these, we do, but because log base 3 of 4 is not a nice number, and log base 3 of x we don't know, we're just going to leave it as is. Down here, the next one, we have log base 5 of 2 times x to the 5th, so we don't have any division, but we do have multiplication, so I'm going to write it as log base 5 of 2 plus log base 5 of x to the 5th. Log base 5 of 2 I can't do anything with. However, log base 5 of x to the 5th, I can take this exponent and put it out front. When I do that, I actually get log base 5 of 2 plus 5 log base 5 of x. And that's expanded all the way. I can't do anything else with it, and so that's my final answer. And then my last one here has division in it. And so with division, I'm going to say log base 2 of 2/5 is log base 2 of 2 minus log base 2 of 5. Now log base 2 of 2, that's like 2 to what power is 2? We know that's equal to 1, so I can simplify that and say 1 minus log base 2 of 5. And so that's how we expand these out. All right, sorry about that. So that's expansion. We could do some of these examples, but I'm probably going to save that for another video. Condensing, same ideas here, okay? We're looking for numbers out in front first, and then multiplication and division multiplication and division comes from addition and subtraction, so we're going to look for that. So right here, I'm looking and I see natural log of 12 minus the natural log of 4. No numbers out in front, so there's no exponents, but there's subtraction. Subtraction means division. Now, as I said earlier, we want to make sure we write it as a single log. So it's the natural log of 12 divided by 4, which is the natural log of 3. That's our simplified version. What some people do, and you should make sure that you do not do this, is you do the natural log of 12 over the natural log of 4. That's incorrect. Okay, we don't write it as a log divided by a log. The next one says 2 log of x plus log of 11. Well, I do see numbers out front, so that's going to become an exponent. So I'm just going to write it right below here, log of x squared plus log of 11. I see addition, and so since it's addition, I'm going to go ahead and multiply, and 11 times x squared is 11x squared. I sometimes like to put these in parentheses just to make sure that I know I'm taking the log of the entire thing, but that's what we get. And then the last one that we have here says log base 3 of x minus 2 log base 3 of z. First thing I notice is there's a 2 there, so I'm going to make that an exponent. So we're going to write log base 3 of x minus log base 3 of z squared. The subtraction means to divide, and so I'm just going to write this as log base 3 of x over z squared. And that's my division. And again, I write it as a single logarithm, not as a log divided by a log, and that's my final answer. Again, we have some examples that can work on condensing, but we're not going to do those right now. And then the change of base. The change of base is kind of working itself out, because now we have the Inspire that can do log base 2 of 8 or something along those lines. Or log base 2 of 12, or log base 4 of 21. But the change of base rule is for when we only could use common logs or natural logs. And here you see log base 2 of 8. We could write that as the log of 8 divided by the log of 2. And when I do that in my calculator, I'm going to get an answer. And in this case, the answer is going to be 3, because we know 2 to the third power is 8. We don't need to use the change of base rule there. But for something like this, we could write it as the natural log of 12 over the natural log of 2. And when I do that, that's going to give me a decimal equivalent. Notice here I use the common log, here I use the natural log. It does not matter which one you use. Use whichever one you feel more comfortable with, or whatever your calculator will do for you. And then the last one here is log base 4 of 21. Again, I could write it as the log of 21 over the log of 4. And I'm just going to click over here to the calculator real quickly, and if you see, I could do right here, control log base 4, base 4 of 21. And this is why we don't necessarily need to know the change base, especially if you have an Inspire. Or I could do the log of 21, and then move out, divided by the log of 4. And you see that gives me the same thing. Or I could do natural log. Natural log of 21, close that parenthesis, divided by natural log of 4. And you can see all 3 ways here I have the same answer. Log base 4 of 21, the Inspire does, gives us 2.196. Log base 10 of 21 over log base 10 of 4, 2.196. And the natural log of 21 over the natural log of 4, 2.196. And so those all work out the same way, and that's the change of base rule. So I hope you learned something. Hope this helps, and we're going to use these properties to solve logarithmic and exponential equations in the next video.